Good day, everybody. Today we are going to talk about freefall from rest. Now, these notes also have a corresponding YouTube video that you can view, which is linked in the same Google assignment. So the first thing that we want to observe is that when an object is dropped, it's going to fall towards the ground. Now, this is pretty obvious. I don't think anyone is particularly surprised by that statement. The question, though, is does it accelerate or move at a constant rate? Well, we can reason that it must accelerate, since when we're holding it still, it isn't moving, and then when we let it go, it is moving a moment later. Therefore, there is a change in velocity, which means it must undergo an acceleration. So gravity is an acceleration. And then the second question is, does the mass or the size of the object affect the rate at which it falls? So here's where you want to go to that YouTube video and take a look at what happens when they drop the feather and, in the video's example, a bowling ball. So when they drop the two, which hit the ground first and why? Now, the next thing they do is pull all of the air out of the chamber. So in a vacuum, which one hit the bottom first and why? This explains Galileo's law of falling bodies, which states in the absence of air resistance, all objects accelerate towards the Earth with the same rate. So freefall. Freefall is a quantity or a state of motion that occurs anytime an object moves through the air only being affected by gravity. Examples of freefall include a baseball being hit up into the air, a rock being dropped from a cliff, or a skydiver without a parachute. Notice that it doesn't matter whether the object is initially moving upwards or downwards. All that matters is that it's moving through the air, only being affected by gravity. Something like a skydiver with their parachute open or an airplane are not in freefall because there are other forces involved. Now, it's important to pay attention to the direction of the object. We are going to treat the downward direction as negative. Since the downward direction is negative, that means that gravity will always be a negative quantity. We can use our kinematic equations to get these expressions. Gravity is equal to the final velocity divided by time. The final velocity squared is twice the gravity times the height, and height is equal to half of the gravity times time squared. The y value indicates the height of an object. Officially, it represents the vertical displacement. So y can be positive or negative depending on direction. Gravity is 9.81 meters per second squared, which we round up to being 10 meters per second squared. It moves in the negative direction because gravity points down. Now, the term dropped means that the object started at rest. So the next examples that we are going to take a look at occur when an object is dropped, and we want to use these three equations to solve them out. So I would like you to give these three examples a try on your own. So the first example says a rock is dropped from the top of a 200-meter high cliff. How long until it hits the ground? In number 1, you are going to solve for time. Number 2, a ball is dropped off of the Empire State Building, 381 meters tall. How fast will the ball strike the pavement below? you're looking for final velocity. And lastly, a skydiver free falls for 9.5 seconds. If he jumped out of the plane vertically at rest, how fast will he be going and how far will he have fallen? You will be looking for final velocity and vertical displacement in this problem. Just a note, in all three of these problems, the object is traveling downward, so your y value must be negative. Give these three a try, regardless of whether you get the answers or not. Take them as far as you can go, and then we will go over these in class tomorrow.